Hello, welcome to this video of mine. I am Ayan. First of all, a few gentle reminders. I am not any teacher, I am not any study guru or sort of things like that. Being a learner myself, I can just elucidate the things and can make you understand the things in a simpler, better and in a crispier manner. So, to begin with, our today's topic of discussion will be the cardiac cycle. So, what is a cardiac cycle? Cardiac cycle is a sequence of events that take place during a heartbeat. Simple as that. That's it. Now we will know about the duration of the cardiac cycle. As you all know, our heart rate is 72 beats per minute. So each beat takes about 60 by 72 seconds, right? That comes out to be approximately 0.8 seconds. Okay, so the duration of the cardiac cycle is 0.8 seconds. Cardiac cycle has further been divided into two kinds of events, atrial events and ventricular events, because heart consists of both atria and ventricles. So cardiac cycle consists of two kinds of events, atrial events and ventricular events. Each event has further been divided into two kinds of phases. Atrial events has been divided into atrial systole and atrial diastole. Atrial systole and atrial diastole. As you all know, systole means contraction and diastole means relaxation. And ventricular events has further been divided into two kinds of phases, that is ventricular systole and ventricular diastole. As the sum of the two events has to make up 0.8 second, we have to divide the two phases according to their time in time. Atrial systole takes up to 0.1 second. 0.1 second. That means atrial diastole has to take 0.7 second. And the ventricular systole takes 0.3 second. And the ventricular diastole has to take 0.5 seconds. Because it has to make up 0.8 seconds, right? So both of them makes up 0.8 seconds. If you look at the time carefully, you will get to see that the atrial events and ventricular events must overlap, right? Now we will discuss cardiac cycle under the following. So first we will see the phases of cardiac cycle. Phases of cardiac cycle separately. Then we will get to know about the heart sounds. Then finally we will jump to a graph called pressure volume curve. Obviously if time permits, otherwise I will not be able to tell, right? Okay, now come to the phase. Let me draw one side of heart. I will be discussing the events only for the left side of heart. The right side of heart will follow the same sequence of events. So discussing the one side will be more than enough. Let me draw the left side. This is the left side of the heart. Now we will divide the left side into 3 chambers. This is the input chamber. This is the pumping chamber. And this is the output chamber. Let me make the things a bit more colorful. Fine. So the input chamber is nothing but the left atrium. The pumping chamber is nothing but the left ventricle. The output chamber is nothing but the aorta. Now between the chambers we will have the presence of valves. Between the left atria and the left ventricle we will have the presence of mitral valves. Let me draw these valves. This is a valve. This is called mitral valve. And between the left ventricle and the aorta we will have presence of another valve, that is called aortic valve. Now keep some things in mind, that the mitral valve will pass blood from left atria to the left ventricle only, but it will not give passage to the blood from left ventricle to left atria. In the similar manner, aortic valve will give passage of blood from left ventricle to aorta only, not from aorta to the left ventricle. So let me write the things. Mitral valve always gives passage of blood from left ventricle to the, it will be left atria. Left atria to the left ventricle. Now see a thing, if blood comes from left atria to the left ventricle, atrial pressure must be higher than the ventricular pressure, right? So that means atrial pressure must be greater than the ventricular pressure. That is quite simple, right? In the same manner, aortic valve will give passage of blood from the left ventricle to the aorta. That means in order to pass blood from left ventricle to aorta, left ventricular pressure must be higher than the aorta's pressure. So let me write these things for you. Left ventricular pressure must be higher than the aortic pressure. So I am done with the basics. Now come to the phases. Okay, now let me draw a heart, a very beautiful heart. Okay, so this is the left side of heart, and as I said, this will be the mitral valve, this will be the aortic valve. Let me mark this for you. In this phase, atria starts to contract. I am showing this like that. Atria starts to contract. That means it will squeeze blood into the ventricle. But let me tell you a fact, the ventricle is already 80% filled. In the beginning of this phase, it is already 80% filled with blood. It is 80% filled. So the atria will just carry out the rest 20% filling. Before contraction in the ventricle, the pressure is before contraction, the ventricular pressure is 0, which is lesser than the atrial pressure. That's why mitral valve is open, but the ventricular pressure is less than the aortic valve. That's ventricular pressure is less than the aorta. That's why aortic valve is closed. Okay, you can clearly see atria is contracting and ventricle is relaxing. So we will write it like that: atrial systole and ventricular diastole. So this was the first phase. So in this phase atria is contracting. That's why we will name the phase as phase of atrial contraction. Let me write this thing. Phase of atrial contraction. So this phase is over. Now we will come to the second phase in the next page. Let me draw the heart once again so that I can show you. This is the heart. So this is the left atria. This is the left atria. This is the left ventricle. This is the aorta. In this phase, atria starts to contract. In this phase, atria has squeezed enough blood into the ventricle. As a result, ventricular pressure is increased by some amount. The ventricular pressure in the beginning was 5 mmHg. It gradually increases and it reaches up to 80 mmHg. Now, the pressure of ventricle is greater than the pressure of atria. As a result, what happens? As a result, the mitral valve closes. Mitral valve closes. So we have a closed mitral valve. But the pressure is still lower than the aorta. Pressure of aorta greater than the pressure of atria. Pressure of ventricle also. So pressure of aorta is greater than the pressure of ventricle. That's why the aortic valve will also be closed. Now, as you can see, the ventricle is contracting and atria is relaxing. So this is atrial diastole and ventricular systole. As you can see, ventricle is closed from every side. So ventricle contracts as a closed chamber. As a closed chamber. Volume of ventricle is constant. So this is called isovolumetric or isometric contraction. Isovolumetric or isometric contraction. In this phase, atria only behaves as a tank. It receives the venous return from the lungs. So let me draw the lungs. Atria behaves as a tank. And talking about the aorta, aorta squeezes the blood into the peripheral arterial tray. Aorta squeezes blood into peripheral arterial tray. So this was the second phase that we will call the phase of isovolumetric contraction. Coming to the next phase, let me draw the heart once again. As I had discussed earlier, the ventricle was contracting. So let me show that. Ventricle is contracting. Now, as the ventricle is contracting, the pressure in the ventricle will go high up. In the previous phase, the pressure went up as high as 80 mm of Hg. It will go further higher. In this phase, 5 mm Hg rose up to 80 mm Hg. It will further go up to 120 mm Hg. Now, the pressure of ventricle will be higher than the pressure of aorta. Pressure of ventricle will be higher than the pressure of aorta. As a result, the aortic valve is open. But again, pressure of ventricle is greater than the pressure of aorta. That's why the mitral valve will be closed. Mitral is closed. And aortic is open. Now the blood will get squeezed from the ventricle into the aorta as the aortic valve is open. The blood will be squeezed from ventricle to the aorta. Aorta is made up of elastic tissue. As a result, aorta will stretch out. To give passage to more and more blood. And ventricle is connected with the aorta. They together act as the same chamber. Ventricle and aorta acts as same chamber because they are connected, right? As the blood is rapidly ejected from ventricle to the aorta, this phase is called rapid ventricular ejection phase. So this phase is called rapid ventricular ejection phase. Let's come to the next phase. As we all know, nothing good really lasts forever. So goes with the rapid ventricular ejection phase. It does not last long. Let me draw the heart once again, as I have been doing. Now, the pressure had reached previously to 120 mmHg. From 5 mmHg, it went up to 80 mmHg, and in the last phase, it went up to as high as 120 mmHg. Now, in this phase, the pressure will fall from 120. It will start to fall. As the pressure will fall, the course of blood from ventricle to the aorta will also be lower. Let me show you this. Blood was ejecting. In the previous phase, blood was ejecting rapidly, but in this phase, as the pressure has fallen from 120 mm Hg to a lower value, the blood will still be ejecting but with a slower pace. But let me mention, pressure of ventricle is still higher than the pressure of aorta. Sorry, it will not be aorta. Pressure of ventricle will be higher than the pressure of atria. That's why the mitral valve will again be closed. Mitral closed. So mitral valve will again be closed, and atria will act again as the tank receiving blood from the lungs. In this phase, atria is in a diastolic phase and ventricle is in the systolic. So this phase will be named as slow ventricular ejection phase. Now let's come to the next phase. In this phase, the pressure of the ventricle will further go down. In the previous phase, the pressure had go down from 120 mm Hg to a lower value. It will further go down in this phase. So let me draw the heart once again. In this phase, the pressure will go down from 120 mm Hg to a very low value, so that the pressure of the atria is less than the pressure of ventricle. This will lead to the mitral is again closed. That means the pressure has gone so low, but still it is greater than the pressure of atria. Now in the last phase, pressure of ventricle was higher than the pressure of aorta. As you can see, that's why it was slow ventricular ejection phase. Pressure of ventricle was higher than the aorta. But in this phase, ventricular pressure will not remain higher than the aorta. It will be lowered than the aortic pressure. That will lead to the closure of the aortic valve. So mitral valve is closed, aortic valve is also closed. In this phase, ventricle is again behaving as a closed chamber and it is relaxing. So it is the phase of isovolumetric relaxation. Let me write this. And it is relaxing as the pressure is going down. Okay, so in this phase, both atria and ventricle are in the diastolic phase. So it is atrial diastole and ventricular diastole, both are in the diastolic phase. This is the phase of isovolumetric relaxation. Let's come to the next phase. In this phase, the ventricular pressure further goes below. Now it is less than the atrial pressure. Now let me draw this once again. Now the ventricular pressure goes further below. Now the pressure of ventricle is less than the pressure of atria. That's why the mitral valve will be open in this phase. but the ventricular pressure is still less than the aortic pressure. For the first reason, the mitral valve will be open. For this reason, aortic valve will close. Fine, the mitral valve will close. Now the ventricle will have some amount of blood left out after the slow ventricular ejection phase, which is called end systolic volume. It will have some amount of blood, which is called end systolic volume. End systolic volume. Which is present as a consequence of slow ventricular ejection phase. Now blood from the atria will come to the ventricle, but it is not contracting. Atria is not contracting. Atria is relaxing. Ventricle is also relaxing. So it will be atrial diastole and ventricular diastole. As atria is not contracting, this feeling will be passive. So this is called rapid passive ventricular filling. Rapid passive ventricular filling. Because atria is not contracting, atria is relaxed. That's why it is passive. So this phase is called rapid passive ventricular filling. This is fifth phase. Let's come to the next phase now. In the next phase, some amount of blood gets deposited due to rapid passive ventricular filling. That is the previous phase. Let me draw the heart for the infinite time. So in this phase also, the two valves as I was saying, in this phase the two valves will be in the same position. That is, mitral valve will be open and aortic valve will be closed. Now, as I said, after the rapid passive ventricular filling, some amount of blood will be deposited in the ventricle over the end systolic volume. So this point will be end systolic volume, and some amount of blood will be there accumulated as a result of rapid passive ventricular filling. Let me denote this. This is end systolic volume. And the above one is rapid passive ventricular. The below one is end systolic volume, and the above one is rapid passive ventricular filling. Let me write this. End systolic volume. Now one is rapid passive ventricular filling. Alright. Now the atria is receiving the venous return continuously from the lungs. Venous return is coming to the atria continuously. And this venous return directly passes into the ventricle. That is why atria acts as a conduit. Conduit or passage of blood. It does not act as a reservoir. It was acting as a reservoir in the previous phases, but in this phase it is not acting as a reservoir. Okay. Now this phase is over. This phase is called slow passive ventricular filling. Or diastasis. In this phase also, atria and ventricle both is relaxing. So we can say that it is atrial diastole and ventricular diastole. So let me write this: atrial diastole and ventricular diastole. So after this phase, again the first phase comes up. In the first phase, we saw that 80% blood was already filled up in the first phase. So 80% blood comprises of this end systolic volume and rapid passive ventricular filling. These two make up to be that 80% of blood. After that, that first step will repeat again, and the cardiac cycle will go on and on and on. So let me write: after this phase, first phase will repeat, cycle will go on and on, cycle will go on and on. So we are now done with the basic events which happen in a cardiac cycle. Now let's proceed to our next topic, which is heart sounds. Now let's have a recap to understand the heart sound. So this phase was phase of atrial contraction. In atrial contraction, the mitral valve was open. At the end of atrial contraction, mitral valve closes. And this closure of mitral valve produces a sound which is called the first heart sound, or S1. So S1 is produced at the end of atrial contraction or at the beginning of isovolumetric contraction. Now again, in slow ventricular ejection phase, the aortic valve was open because it was ejecting blood from ventricle to the aorta. But when it proceeds to the isovolumetric relaxation, the aortic valve closes, and this closure of aortic valve produces a sound which is called the second heart sound, or S2. So S2 is produced at the end of slow ventricular ejection phase or in the beginning of isovolumetric relaxation. So let's jot down the points and we'll proceed further. So as I said, let's first write the sound S1. S1 is produced ventricular systole. It marks the closure of mitral and tricuspid valves. Tricuspid valve is present in between the right atria and right ventricle, as I had discussed for the left portion only. So I had mentioned the mitral valve. Tricuspid valve will be applicable for the right side of the heart. Now let's come to the S2. We will use a different color. S2. S2 marks the closure of aortic and pulmonary valves. But this is not the end. We have two more heart sounds, S3 and S4. Let's know about them. we'll know about S3. During rapid passive ventricular filling, there may be a sound. Which is nothing but the S3 only. Now we will come to S4. Let's use a different pen. Remember one thing, for God's sake, that S4 is always pathological. It is never present in a normal human being. Healthy man. And how it is produced? When atria contracts against the hypertrophied ventricle, S4 is produced. So when atria hypertrophied. Now, what is hypertrophied? Hypertrophied is nothing but enlarged. If your ventricle is enlarged, it is called hypertrophied. So when atria contracts against a hypertrophied ventricle, it has to put an extra effort. Sound wave produced, that is S4. That is nothing but S4. So we are almost done with the heart sounds. And remember one thing, the opening of the valves never make any sound. Opening never makes any sound. So let me write that also. Opening of valves So we are done with the heart sounds. We will now jump to our last segment, that is the pressure volume curve. So our next topic is pressure volume curve. Let me write this, pressure volume curve. Then we will end up this session. Pressure volume curve or PD graph. As we all know, a graph has two axes, the x-axis and a y-axis. So let me draw two axes in this graph also. Sorry. This is the x-axis and this is the y-axis. Let's know what these two axes denote. Along the x-axis, we will put volume of what? Volume of not atria, volume of ventricle. And along the y-axis, we will put pressure of the ventricle, not the atria. Remember this thing. Pressure of the ventricle. Now let's start with the first phase. Remember people, the first phase was of atrial contraction. In this phase, the blood from atria will be ejected to the ventricle. That's why the ventricular pressure will increase a little bit. So let's denote this in the graph. Okay, using a different color. The ventricular pressure is increased a little bit. Ventricular pressure is increasing, as well as the volume is increasing as the blood is coming to the ventricle from the atria. After that, remember there was a phase called isovolumetric contraction. That means the volume will be constant And as I had mentioned earlier, the ventricle will contract as a closed chamber. So the pressure will go high up from 5 mm Hg to 80 mm of Hg. I had mentioned in the previous slides. So let me draw isovolumetric contraction. So this is isovolumetric contraction. After the isovolumetric contraction, the aortic valves will open. So the blood from the ventricle will go all the way to the aorta. That was the rapid ventricular ejection phase. So let's draw the rapid ventricular ejection phase. During the rapid ventricular ejection phase, blood from the ventricle will go to the aorta. That's why volume will decrease in the ventricle, and pressure will go high up a little bit because ventricle is still in systole. Ventricle is contracting. It is ejecting out blood to the aorta. So let's draw the rapid ejection phase. Sorry. So this is the isovolumetric contraction. Isovolumetric contraction in rapid ejection phase. This is the rapid ejection phase. After the rapid ejection phase, the course of blood will slow down, and the pressure of the ventricle also will go down, and the volume will obviously go down. So pressure will decrease, volume will decrease. So let me draw the slow ejection phase that comes after the rapid ejection phase. So that is the slow ejection phase. So this is the line which marks the pressure of 80 mmHg. That marks the pressure of 80 mm of Hg. Okay. Now after slow ejection phase, we had isovolumetric relaxation phase. During the isovolumetric relaxation phase, the volume will remain constant, the pressure will decrease in the ventricle. So let me draw this. And after the isovolumetric relaxation phase, the pressure will go down all the way to zero. All the way to zero. Sorry. Pressure had gone all the way to zero. Now here comes the rapid passive filling. During the rapid passive filling, the AV valves will open, or the mitral valves will open. So the blood from the atria will go rapidly into the ventricle, and the ventricular pressure will go a little higher. After that, slow passive ventricular filling will follow, which is also called diastasis. And after that, the first phase will repeat itself, which I had drawn earlier, and the cycle will go on and on and on. So let me draw the rapid passive filling and slow passive filling phase. It will be like that. Sorry. This will be like. And this is the rapid passive filling phase. So we are done with the graph. Let me mark some important things in the graph. This point on the graph marks the beginning of isovolumetric contraction, or it is the closure of the mitral valve. Or you can say AV valve. It is followed by the isovolumetric contraction. Then there will be opening of aortic valve. This point marks the opening of aortic or semilunar valves. That is followed by rapid ejection and slow ejection respectively. and this is slow ejection. This point marks the closure of semilunar valves. And this phase is isovolumetric relaxation phase. Isovolumetric relaxation phase. After the isovolumetric relaxation phase, the mitral valve will open this point. Mitral valve will open, mitral or AV. Now the curved line below, as you can see, curved line below can be divided into 3 phases. Let me divide these into 3 phases, then I will explain 3 phases. The first phase will be rapid passive filling, second phase will be slow passive filling or diastasis, and the third phase will be atrial contraction. That was the first phase. First phase is rapid passive filling. Rapid filling is enough. Slow filling, and it is followed by atrial contraction. The first 2 phases are called passive filling, and the next phase is called active filling. So we are almost done with the topic. Slow filling is also called diastasis. Forgot to mention diastasis. So I hope you have understood this graph thoroughly. And last but not the least, if you get any sort of help from this video, it will be very blissful for me. And thanks to Shubhan sir for giving me such an opportunity, which is beneficial for my academics as well. And thank you so much, people. Thank you.